In this tutorial, we're going to look at promises in JavaScript and how you can use them to deal with sequencing in your asynchronous JavaScript code. So we'll first look at what promises are, how to create them and use them, and then we'll take a look at a few examples of how they solve problems with asynchronous JavaScript code. So a promise object intends to give you either a success or a failure after it's completed some task that potentially might take some time to complete. So when creating a new promise, you actually pass one argument to it, which is a function, which itself has two arguments, resolve and reject. So if we just examine the promise that we've just created, you can see from the output on the right hand side that it's in a pending state. That means we're still waiting for the promise to complete with either a success or a failure. And we need to set up some next steps to deal with those successes and failures in a similar way that we would if we were creating an event listener within our browser. So for a success, there's a property on the promise object called then, which again takes another function as an argument, which gives us any data that's passed back from the promise if it's successful, and there's also a catch property, which will also receive any data that's passed back if the promise fails. So you'll notice we've got no output whatsoever at the moment, so within our promise we need to indicate whether or not we have a success or a failure. And we do that using the resolve and the reject parameters that are inside our promise, and they are actually both functions, so we can use those to trigger either a success or a failure. So in this case, we're actually triggering the function on the then property, and just to prove that, we'll prefix the result. And as you might expect, if the promise was to fail, we can use the reject function. So in reality, we wouldn't just return resolve or reject without first doing some asynchronous task, which might be a network or file operation, but let's just simulate that with a set timeout. And you'll notice now when the code runs again, there's a slight delay before the then block is triggered, as we're waiting for the set timeout to complete before the resolve function is called. So let's have a look at how you might use a promise with a simple example. So here we have a simple asynchronous function that returns a random number after a certain delay, which in reality could be a network file or any other asynchronous operation. So if we log something out to the console before we call this function, obviously that string we're logging to the console is displayed first. So if you wanted to display the string after the number has been generated, you could conceivably put that inside of the async function, but to separate our concerns and to keep things tidy, we can put the console.log inside of a then statement. And because we have the result from the resolve function, we can display that first, or at least make use of that data, before our initial console.log. And of course, if there is any problem with the data from the asynchronous operation, we can always call the reject function. So just by using the simple pattern of resolving or rejecting based on good or bad data, you can effectively control the output and operation of your asynchronous code. So there are also a few static properties that are available on the promise object. For example, you might want to call several promises at the same time. For example, with our simple function, we can generate 3 random numbers, and you pass those calls to the asynchronous function into the promise.all static function, and then you can still access the then property to see the data that's returned. And also the catch property if there are any errors. The only caveat with the promise.all function is that if one of those asynchronous operations does fail, it will actually stop you getting the results from the other ones as well. So let's just remove the reject from the function. So now you can see in our then block that we have an array of random numbers that are generated by those 3 asynchronous functions. So this might be useful if you're sending multiple network requests to different sources and you want to send all of those requests at the same time, and access the result of those three functions in the then property of the promise.all function. Finally, there is also a promise.raise function available, which, as the name suggests, will actually return the data from the promise that finishes first. So running that a few times, you can see the random value that's the smallest, which is used as the set timeout delay, is actually the one that's returned from the promise.raise function. So that could be useful if you have data from multiple sources that you're accessing, and once you've returned a value from one source, you can disregard any data that's returned from any additional sources.